In the frozen fields of eastern Ukraine, a revolution in warfare is unfolding. While Russia throws waves of outdated armor into the meat grinder, Ukraine has turned the battlefield into a laboratory, and the results are leaving military experts worldwide speechless. Over the past 72 hours, Ukrainian forces have demonstrated a tactical innovation that's rewriting the rulebook on modern combined arms warfare. Using a coordinated network of FPV drones, electronic warfare systems, and precision artillery, they've created what military analysts are calling a digital kill box, a zone where Russian armor doesn't just get destroyed, it gets systematically hunted. This isn't just another battlefield update. What we're witnessing represents a fundamental shift in how modern warfare operates when innovation meets desperation, when creativity trumps raw numbers. And the implications stretch far beyond the fields of Donetsk. For months, Russia has relied on a brutal but simple strategy: overwhelm Ukrainian defenses with sheer volume. Waves of T-72 and T-80 tanks, supported by mechanized infantry, pushing forward regardless of losses. The math seemed simple. Russia has more equipment, more ammunition, more bodies to throw into the fight. But Ukraine saw a different equation. With limited armor reserves and a desperate need to maximize every asset, Ukrainian military planners turned to an unlikely solution: weaponized swarm tactics using commercial drone technology modified for military applications. The result? In a single 48-hour period last week near Avdiivka, Ukrainian forces destroyed 23 Russian armored vehicles, including 7 main battle tanks, without losing a single Ukrainian tank in direct engagement. Here's how the system works and why it's so devastatingly effective. Ukrainian forces have created what they call drone hunting packs, coordinated groups of 8 to 12 FPV drones operating in synchronized waves. Each pack includes spotters equipped with thermal cameras, jammers carrying electronic warfare payloads, and strikers loaded with shape-charge warheads capable of penetrating up to 200 millimeters of armor. The spotters identify targets and relay coordinates in real time through encrypted Starlink connections. The jammers move in first, disrupting Russian communication and counter-drone systems. Then the strikers attack in rapid succession, not randomly, but targeting specific vulnerabilities: engine compartments, ammunition storage, optics systems. According to data released by Ukraine's Ministry of Defense, these coordinated drone strikes achieve a 73% first-hit success rate against moving armor, a figure that would have seemed impossible just 2 years ago. For context, traditional anti-tank guided missiles typically achieve 40 to 50% first-hit rates under combat conditions. Colonel Markus Reisner of the Austrian Armed Forces, one of Europe's leading armor warfare experts, analyzed the tactics in a recent briefing. What Ukraine has developed is essentially a distributed anti-armor network that operates faster than human reaction time. By the time a Russian tank commander realizes he's under attack, 3 or 4 drones are already inbound from different vectors. But here's the critical question that's keeping defense ministers awake at night. If Ukraine, operating on a fraction of NATO's defense budget, can develop these capabilities in the middle of an existential war, what could a peer adversary like China accomplish with years of preparation and unlimited resources? The answer is uncomfortable. The era of traditional armored warfare, where tanks dominated the battlefield through a combination of firepower, protection, and mobility, may be ending. Not because tanks are obsolete, but because the cost-benefit equation has fundamentally shifted. Let's examine a specific engagement that illustrates these principles in action. On November 4th, near the village of Stepov in Donetsk Oblast, a Russian mechanized company, approximately 10 tanks and 15 infantry fighting vehicles, attempted to exploit a gap in Ukrainian lines. Ukrainian reconnaissance drones detected the movement 40 minutes before the Russian force reached its jump-off point. Rather than engaging immediately, Ukrainian forces allowed the Russian column to advance into a pre-designated kill zone, an open field with limited cover, flanked by tree lines where Ukrainian infantry could position anti-tank teams. As the Russian armor entered the kill zone, Ukrainian electronic warfare units activated jamming systems, cutting the Russian force off from command and control. Simultaneously, the first wave of FPV drones struck, not the tanks, but the accompanying infantry fighting vehicles. Within 3 minutes, 5 IFVs were disabled, forcing their infantry to dismount into the open. The Russian tanks, now without infantry support and unable to communicate with their command, attempted to retreat. That's when the second drone wave hit, targeting the lead and trail tanks to create a traffic jam. Ukrainian artillery, pre-registered on the kill zone, began firing precision strikes guided by drone spotters. The entire Russian company was destroyed or disabled within 18 minutes. Ukrainian forces suffered 0 casualties. The drones themselves represent a fascinating case study in battlefield adaptation. Most Ukrainian FPV strike drones are built around commercial racing drone frames, typically 7 to 10-inch models originally designed for competitive racing. These frames are modified with reinforced motor mounts to handle the additional weight of military payloads, typically 1 to 3 kilograms of explosives. The warheads are often improvised but increasingly sophisticated. Early versions used simple contact fuses with RDG, 5 grenade charges. Current iterations employ shaped charges with copper liners, designed to penetrate armor through focused explosive energy, the same principle used in anti-tank missiles costing thousands of times more. Control systems have evolved dramatically. First-generation combat drones used standard analog video transmission, vulnerable to jamming and limited in range to 2 to 3 kilometers. Current systems employ digital encrypted links with automatic frequency hopping, extending effective range to 8 to 10 kilometers while maintaining resistance to electronic countermeasures. Footage from Ukrainian units shows the reality on the ground. In one verified clip from November 7th, a Russian T-80 BVM, one of their most modern tanks, is struck by 4 FPV drones in the span of 34 seconds. The first drone disables the active protection system. The second targets the engine. The third and fourth penetrate the turret ring, causing a catastrophic ammunition detonation. The tank's crew never had time to retreat. The entire engagement, from first detection to complete destruction, lasted under 2 minutes. The numbers tell a stark story. In October 2024, Ukrainian drone units operating in the Donetsk sector recorded 847 confirmed armor kills. That's more than 1 Russian armored vehicle destroyed every hour, around the clock, for an entire month. The cost differential is equally stunning. A modified FPV drone with a military-grade warhead costs Ukraine approximately $400 to $600 to produce. A Russian T-72B3 tank costs roughly $1.2 million. Even accounting for the multiple drones often required per kill, Ukraine is trading at a cost ratio of approximately 1 to 200. But the impact goes beyond simple economics. Russian forces are now forced to operate their armor in ways that fundamentally compromise their tactical effectiveness. Tanks advance with reduced infantry support because troops refuse to cluster near vehicles that have become drone magnets. Armor units avoid open terrain, limiting their mobility and firepower. Command vehicles stay farther from the front, degrading coordination. This tactical evolution didn't happen overnight. It's the result of brutal lessons learned through 33 months of high-intensity warfare. In the early months of the invasion, Ukraine lost armor at unsustainable rates, sometimes 15 to 20 tanks per week. Ukrainian commanders realized they couldn't win a war of attrition against Russia's numerical superiority. They needed a force multiplier, something that could offset Russia's advantages in heavy equipment. The answer came from an unexpected source: Ukraine's thriving tech sector and its community of civilian drone enthusiasts. Engineers who once designed racing drones began adapting their designs for military use. Software developers created targeting algorithms. 3D printing facilities started producing specialized components. The Ukrainian military embraced this grassroots innovation in ways that would be impossible in more rigid military structures. Units were given latitude to experiment, to fail, to iterate. Successful tactics spread through Telegram channels and informal networks faster than through official doctrine updates. The implications of Ukraine's drone warfare revolution extend far beyond the current conflict. NATO military planners are watching closely. The U.S. Army's Futures Command has already initiated 3 separate study programs analyzing Ukrainian drone tactics. The UK's Royal Armoured Corps has revised its training protocols to incorporate counter-drone defensive measures. Poland has fast-tracked procurement of electronic warfare systems specifically designed to counter FPV drone swarms. Battery technology remains the primary limitation. Most FPV drones operate for 8 to 12 minutes of flight time. meaning they must be launched relatively close to target areas. Ukrainian forces have adapted by creating mobile launch positions, often just a soldier with a backpack in a tree line, that can rapidly deploy and relocate. Russia hasn't been passive in the face of this threat. They've attempted multiple countermeasures, with varying degrees of success. Electronic warfare has been their primary focus. Russian forces deploy an array of jamming systems, from vehicle-mounted pole, 21 units to man-portable systems carried by infantry squads. These systems can create localized bubbles of radio frequency interference, disrupting drone control signals. But Ukrainian operators have adapted. They've developed autonomous flight modes where drones can complete attacks even after losing connection with their operators. They've created relay systems using high-altitude drones that extend control range beyond jamming zones. They've even employed AI-assisted targeting that allows drones to identify and engage targets without continuous human control. Russia has also attempted to field their own FPV drone capabilities, with limited success. Russian drones tend to be heavier, less maneuverable, and more expensive, often using military-grade components where Ukraine employs modified commercial technology. More critically, Russia lacks the decentralized innovation ecosystem that allows Ukraine to rapidly iterate and improve designs based on battlefield feedback. This tactical revolution raises profound questions about the future of military power. For decades, military superiority has been measured in platforms. How many tanks? How many aircraft? How many ships? The assumption was that advanced, expensive systems would dominate cheaper, simpler alternatives. Ukraine is proving that assumption wrong. What matters now is the speed of innovation, the ability to adapt faster than your opponent, the capacity to turn commercial technology into military advantage before your enemy can respond. In this new paradigm, a $500 drone operated by a well-trained soldier with good intelligence can neutralize a $2 million tank crewed by poorly coordinated conscripts. This has massive implications for how nations should structure their defense spending. Should we continue investing billions in next-generation main battle tanks when those tanks might be obsolete before they enter service? Should we prioritize electronic warfare and counter-drone capabilities over traditional heavy armor? Should we fundamentally rethink how we train and organize ground forces? The U.S. Army is already grappling with these questions. The service's 2024 budget request included $1.3 billion for counter-small unmanned aircraft systems, more than double the previous year's allocation. The Marine Corps has gone further, divesting all of its tank battalions to focus on lighter, more distributed forces optimized for drone-enabled warfare. The drone revolution is accelerating, not plateauing. The message is clear. The future of warfare won't be decided by who has the most tanks or the biggest navy. It will be decided by who can innovate faster, adapt quicker, and leverage emerging technology more effectively than their adversaries.